The last experiment I'd like to quickly overview is the optical reflector materials experiment called ORMATE, and that series has been flown on MISSE. It's a collaborative effort between the Aerospace Corporation and Naval Research Laboratory, and the PI is Ivanka Polasinski. And they have a twofold purpose, and that is to provide a space platform to expose new materials to the space environments and generate on-orbit flight performance data to support space qualification. They're looking at novel optical coatings and mirror substrate materials, and they have a few goals that are common with other MISSE investigators, such as populating databases with the MISSE data, comparing their MISSE data to prior MISSE missions and other spaceflight experiments, such as LDAT. And also, almost all the MISSE investigators understand the importance of using the on-orbit data to combine with ground test data to improve the fidelity of material modeling. The ORMATE series has flown in MISSE 6, 7, and 8, and the benefits are reduced risk of incorporating new technology in future satellite systems. They find it's an inexpensive way to evaluate vendor space readiness on a small scale. They use the MISSE data to educate vendors on making materials that will survive in the space environments with an emphasis on materials processing. And they use the data for space qualification. And lastly, as I mentioned before, they compared the on-orbit results to ground-based testing to improve the fidelity of material modeling and prediction. So in summary, I'd like to say that MISSE is a multi-organizational team made up of participants from NASA, DoD, industry, and academia. It provides long-duration space environmental performance and durability data, such as material validation, space qualification. It provides improved predictions of materials and component lifetimes in space. It allows us to verify models and to develop new models. And it allows us to determine correlation factors between space exposure and ground facilities, which enables more accurate in-space performance predictions based on ground laboratory testing. And I'd like to thank the following people who are listed here, as they have provided information and charts that I used in this presentation. Thank you.